Well, hello 3C, and welcome to lesson 5 of Unit 5. We're talking about present value of an investment today. Our goal, I know how to recognize when I'm being asked for the principal in a compound interest problem, and I can calculate it. So we've been working with compound interest, and up until now, we've just been talking about if I invest so much now, how much am I going to have in the future? Well, today what we're going to talk about is if I want to have this amount of money in the future, how much do I need to invest now? So what we're actually looking for is principal. So take a look. The present value is the amount you wish to invest now to achieve a specific total in the future. In other words, instead of finding amount in the compound interest formula, we're finding the principal. So what we're first going to do is rearrange the compound interest formula to get principal by itself. So if we take a look, we want to get the P all by itself. This whole big thing here is stopping the P from being by itself. So what I'm going to do, since it's multiplying the P, I'm going to divide by it. So I have to divide both sides by 1 plus I to the n. What that does is it allows me to get rid of it on this side because anything divided by itself is just 1. So on this side I have 1 times p, which is just p, and on this side I have a over 1 plus I to the n. Now remember when we worked with exponents that anything that was on the bottom with an exponent, if I wanted to switch it to the top, all I had to do was give it a negative exponent. So it's actually a little easier to plug into the calculator if I do that. If I move this to the top and give it a negative n. So this is a equals, a times 1 plus I to the negative n equals p. Now this looks a whole lot more like the formula we've been using with compound interest. The p and the a have switched places, and I have a negative exponent instead of a positive exponent. This is still number of compound periods. Number of compound periods. This is still interest rate, but it's per compound period. Remember, most interest rates are given by the year, so you have to adjust it for the compound period. The P is still the amount invested, and the A, we're going to call it a future amount. Okay, let's do some examples here. This says, when Ryan was born, his great aunt Zelda decided to dip into her savings and put away some money for his post-secondary education. She estimates that a year's tuition will cost about $5,000 by the time Ryan gets there, and she finds an account that pays 3% interest compounded monthly. So how much should she put away for his first year of school? So I'm going to highlight the important information here. $5,000 is the amount she wants to have saved up for. So it's actually going to be our A value when we start putting things in. The other thing we have here says it's a 3% interest. That is compounded monthly. So monthly is another one. So I'm going to put a couple of things here. First of all, the 3% interest we're going to use is 0.03. And the compounded monthly means 12 times a year. So here's what we're going to do. I'm going to still write down the side. Instead of a pin, I'm going to write pain, P-A-I-N. And the reason I'm going to write pain is that's the order it appears in now. P equals A, 1 plus I to the negative n is our formula now that we're trying to find the P. So I don't know the P. I said this is the amount we want in the future, so it's my A, so $5,000. I is 0.03. However, since it's compounded monthly, I have to divide it by 12. And N is how long? Well, we don't know. It doesn't actually say, but since she invested it when Ryan was born and it's for his post-secondary education, we're going to take a guess of 18 years. And it's 18 years, so we have to times that by 12 in order to get how many compound periods. So let's actually make these two calculations. I'm going to pull up my calculator. 18 times 12 is 216, so we're going to put 216 here. And this next one is 0.03 divided by 12, and that's 0.0025. 0.0025. Now let's actually plug these things in here. So that's 5,000. 1 plus 0.0025 to the negative 216. Now this just has to go into the calculator. Now if you have a decent calculator, you can type it in exactly as it looks and get your final answer. Some calculators like this one that I have here work backwards, and the method that I'm going to show you here works on absolutely every single calculator out there. Okay, so some of you may know a different way to punch it in. If you get the same answer, you're good. Okay, so I have this 0.0225 or 0.0025 on my calculator, so I'm going to do the first thing here. The first thing here was I got this on my calculator. The second thing is I'm going to add 1. Then I'm going to raise it to this exponent, and then I'm going to multiply by 500. So that's the order I'm going to do it in. 1, get this on the calculator. 2, add 1, raise it to this exponent, and then multiply by the number out front. So we're going to add 1. Now remember, you got to hit equals between each and every one of these. I'm going to raise it, so I need the exponent button. On my calculator, it's this one. Raise to the exponent negative 216. Now I have to type in 216, then hit the negative button. Now remember, it's not the minus button, but the negative button. Not this one over here, this one that has a positive and a negative on it. And I have to hit equals. And now the last thing I'm going to do is multiply by 5,000. And hit equals. And so that's 2915.71. 2915.71. Now I'm just going to show that to you again a little bit faster with a little less talk. I'm going to get this on my calculator first. 0.03 divided by 12. And then I'm going to go over to here and I'm going to add 1 to that number that's on my calculator. So plus 1. Hit equals. Raise it to this exponent, this button, 216 negative. Hit equals. And then the last one times by 5,000. So times 5,000. 2915.71. Same answer. Good. We're good to go. Okay. Now it says how much interest will she have earned. So this was part A. Part B says how much interest will she have earned? Well, to find interest, we always take what the bank gave us, which is our amount. So our amount here was $5,000. And we're going to subtract off what I invested. And what you invested is the principal, which in this case is 2915. Whoops. 2915.71. So let's pull up the calculator again. 5,000 minus 2915.71. 2,084.29. 2,084.29. So that's how much interest we earn on that. Okay, next question. Ashley has devised a way to travel back in time to 1908. She wants to advise her great-grandfather to put money away in an account that pays 2.5% interest compounded daily. All right, I'm going to start highlighting things here. 2.5 daily, and she wants $1 million after she returns to the future. So we have to know how many years that is because they didn't tell us. So she returns to the future in 2013. And she was back in 1908. So from 2013 to 1908 minus 1908 is 105 years. 105 years. This money is going to be invested for. And we want to know how much she wants to invest. So let's put our PAIN down the side. PAIN. Principal is, we don't know. That's what we're trying to find. In the future, I want to have an amount of $1 million. I is 0.025, but this says it's compounded daily. So the number that goes with daily is 365. So divided by 365. Now our N is 105 years, but it's compounded daily, so I have to multiply that by 365. Now that's going to be a big number. So let's take out our calculator and calculate these things. I'm going to do 105 times 365 first, and that's 38,325. 38,325. Big number, right? And over here, I'm going to get that on my calculator. I'm doing it seconds, so I can leave it on my calculator. 0.025 divided by 365. That is, and usually I write down 3 decimal places that aren't a 0. So we got 1, 2, 3, 4 zeros, and then 685. 0.1234685. Now when I say I write that down, that's all I'm doing. I'm writing it down. I'm going to use the rest of them. So let's write our formula down. P equals A, 1 plus I to the negative n. And our A is $1 million. Ooh, I've got more zeros than I need over there. Did anybody notice that? Million only has 6 zeros. Okay, $1 million. 1 plus I in this case is the 0.0000685. And it's to the negative, I'm running out of room, 38,325. So 38,325. Now how are we going to punch that into the calculator? Well, I've got this interest rate. Whoop, calculator went away. Okay, I've got this interest rate, so I'm going to add 1. So plus 1, hit equals. Then I'm going to raise it to this whopping big exponent. So on my calculator, I've got to press 38325 first before I hit the negative button to give it that negative exponent. You might be able to press it first. You got to know how your calculator works. Hit equals. Whoops. Okay, that didn't work. Let's try that again. 0.025, I'm going to divide that by 365 to get this number. I'm going to add 1 and hit equals. Now I'm going to raise it. There, that's what I forgot to press. I forgot to press that exponent, and I'm going to put 38325, but it's negative, hit equals. And I'm going to times it by $1 million times 1, 2, 3, 4, 5, 6, 1 million. So we have to have $72,446.27. Okay, so 72446. 72446 and 27 cents. Okay, so that's how much money you'd have to have. Now in 1908, that amount of money would be unheard of to have. So you're probably not going to get to $1 million on 2.5% interest alone. Now, is that our last question? That is our last question. And that ends this video. Thank you for watching. Ta-ta for now.